Hey guys, this is question number 4 for the review for exam number 2. Here we have, they're asking us to find the shear and the moment somewhere between 0 and 4. Okay. Right off the bat, we see this is a 3D problem. I actually found it simpler if I made it a 2D problem. And this is what I mean by that. See how the Z, the X, and the Y, see that could get confusing a little bit. So what I did was I deleted the X and I changed the Z to a Y and the Y to an X. Okay, so we're just working with X and Y, and we make our lives a little simpler. Now this is not true for all the problems, but for this particular problem you can do that because there's no, that won't hurt you. It will just help you a little bit, okay? The next step is kind of like just labeling everything, drawing a free body diagram. I do it right here for you guys. Kind of know where the forces are, right? The reason why I have a single force here is because I drew the force in the centroid, so you do the 4 times 4, which is 16, and to find the centroid, you do the distance divided by 2. So it's 2, and the same thing in this side. So it's 8 times 2, and the distance would be 1. Okay, so it's right in the middle. Since this problem is only asking us for shear in the moment, we don't care about that x, that ax. We don't care about it. Excuse me. We don't care about it. We only care about the y, and we only care about the moment. Okay. So before we split this and we make another free body diagram, we want to find the forces, the unknown. We have two unknowns as of right now. We have the unknown of ay, and we have an unknown of the moment. Okay. Let's start with the y. To find the ay, we're gonna do the forces in the y, and then we're gonna have here is a positive ay, it's pointing up, minus 16. Okay, and for ay we get that is equal to 16. Pretty easy, right? Yep, it's that easy. So that's how easy it is to find the ay. And we want to do the same thing for the moment, right? The moment at A. Now, this is something that I feel like it could bring a question to your mind. Well, how do I know if this moment is going that way or the other way? I'll show you how you know, okay? Let's say this moment is going this way, like I have it. That would make it a positive moment, right? Because it's going counterclockwise. So here it would be MA as a positive minus 16 times 2 minus 8 times 1, right? Here, the answer that you're going to get is going to be 40, right? It's going to be a positive 40. Now, if that moment was going the other way, it was going to the right, that would be a negative moment. So the answer that you would be getting would be a negative answer, which doesn't make sense, right? In this case, so that's how you know the direction of the moment and where it's going, okay? So let's highlight that and move on to the next step. The next step would be just drawing another free body diagram from 0 to 4, because that's what it's asking us to find, right? So this is my free body diagram. Okay. So this is asking us from 0 to 4. We don't care about the right side. We just care from that y is actually given right here too. That's what it's wanting us to find. Okay. So the origin is right here, and we're gonna draw the forces here. And we know that this distance is just simply y. That's the distance, because we don't know. It's somewhere between 0 and 4, but we don't know where that distance is. So the distance is y. Okay? And it's asking us right now to find the shear and the moment in this little point right here. We know that the AY is pointing up, and we know the direction of the moment. So remember, it's going to be opposite of that. So the moment is going to be up, and the shear is going to be down. Okay? Same thing, but opposite. And this force right here, remember how you find that is the 4 times the distance. The force is given times the distance. That's how you're going to find the force. And then the centroid is going to be located at the distance divided by 2. So we know that it's going to be here, right in the middle, right? And it's going to be 4 times y, because of the distance. Again, we don't know it. And the centroid is y divided by 2. Hope that makes sense. Pretty easy enough. I hope that makes sense. Okay, that's important going forward. First thing you want to do is you want to find the forces in the y. So you go here, force over y. So what do we have? We have the AY pointing up. So we have AY minus 4y is pointing down, so it's minus, negative, minus the v, which is what it's asking us for. We already know that the AY is 16, so that makes it 16 minus 4y equals v. Okay, so that's the answer for the v. Alright? Now to find the moment, you want to do, you have your AY, which is AY times y, because that's the distance. And it's going to be negative. The reason it's going to be negative is because it's going clockwise. You have your 4y times your distance, which is 1/2 of y, 1/2 times y. Then your moment, and we already know that the moment is going to be positive because it's counterclockwise, which is this moment right here. Okay. Plus the other moment, which is going to be your m. Now, you may ask yourself, why are both moments positive? Right? The reason that both moments are positive is because we are finding it at this point, right? This moment right here is positive, and this moment it will be negative, but since we're finding it at that particular point, it's going to be going clockwise, counterclockwise. Okay, so you get negative m equals 16y plus 2y squared 40. So the final answer is m equals negative 16y minus 2y squared 40. I didn't mean to put this right here. So 16y minus 2y squared minus 40. And that is the final answer. I hope that helps. Thank you guys.